Trigonometry, Chapter 2, Acute Angles and Right Triangles, Section 3, Approximations of Trig Function Values, Video 2, Using Inverse Trig Functions to Find Acute Angles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we practiced using a calculator to evaluate trig functions. Sometimes we had to resort to reciprocal identities. Sometimes we had to accommodate angle measures in degrees, minutes, seconds by converting to decimal degrees. In this video, we learned to use the inverse trig functions to find acute angles. Before we do that, let's recall an algebra concept, the concept of an inverse function. Suppose f of x is a one-to-one function, which basically means to get equal outputs, you have to start with equal inputs. But f of x is a one-to-one function from domain D to range R. Domain are the inputs, range are the outputs. The inverse function of f of x, denoted f inverse of x, that's how you read this, is the unique function whose domain is R and whose range is D. So the domain and the range switch, that satisfies the following. F inverse of f of x equals x for every x in the domain, and f of f inverse of x equals x for every x in the range. Essentially, the functions undo each other when you put one inside of the other. For example, the function f of x equals 1 plus 1 over x has domain of all real numbers except 0 and range of all real numbers except 1. The domain must exclude a 0 because the denominator, and the range cannot include 1 because you'll never get 1 out of this because 1 over x is never 0. The inverse function, f inverse of x equals 1 over x minus 1, has the domain excluding 1 because that would make the denominator 0, and range excluding 0 because this function can never equal 0. Its numerator is just 1. But to be inverse functions, I have to be able to plug them into each other and end with x. I'm not going to go through all the details, but here's the algebra that verifies the composition of both directions end up with x. What about in trig? Well, that's what I just said. Later, we'll get into all the details about inverse trig functions, such as addressing the fact that none of them are one-to-one, a problem that has to be remedied in order to define the inverse trig functions. For now, we're going to limit ourselves to quadrant 1 angles, acute angles, where trig functions are one-to-one. In other words, all trig functions are invertible in quadrant 1. Meaning, give me the answer, I can tell you the angle that we had. So, suppose for some acute angle theta, we have sine of theta is equal to x. We define the inverse sine function, written as sine inverse of x, as the function that returns the unique angle theta as its output. In other words, if sine of theta is equal to x and theta is acute, then sine inverse of x is equal to theta, so it reverses the sign. Similar definitions can be defined for other trig functions. Again, for this video, we're assuming the angle is acute. Now, to evaluate inverse trig functions of sine, cosine, or tangent, you simply use the inverse trig keys on your calculator. For example, if we wanted to find the acute angle theta that satisfies sine of theta equals 0.967709115, then we would just have to use the inverse sign on that value. Theta would equal the inverse sine, or sine inverse, of 0.967709115, and it ends up being approximately 75.399995 degrees. So we just did sine backwards. However, to evaluate inverse trig functions of secant, cosecant, or cotangent, we have to incorporate reciprocal identities, unless your calculator has those inverse trig functions. For example, if we wanted to find an acute angle theta that satisfies secant of theta equals this number, and our calculator doesn't have secant inverse, then we have to capitalize on reciprocal identities. Otherwise, just enter this. If we can't just enter that, then we would capitalize on the fact that if secant of theta is equal to this number, then cosine of theta is the reciprocal of that number. In this equation, we can use cosine inverse on. We would get theta as cosine inverse of that fraction, which gives us about 18.5 degrees. So just to review really quickly, if you are trying to find an acute angle of secant, cosecant, or cotangent that equals a given value, and you want to use inverse trig functions, and your calculator can't just do inverse trig functions of secant, cosecant, or cotangent, Then you would rewrite the original equation in terms of cosine, sine, or tangent, and then use one of those inverse trig functions to produce the value. In general, to find cosecant inverse of x, you find sine inverse of 1 over x. Secant inverse of x is cosine inverse of 1 over x. Cotangent inverse of x is tangent inverse of 1 over x, assuming x belongs to the correct domains. Now you try. Pause the video and try the following. Use a calculator to find the missing acute angle. All right, here's your fair warning if you haven't paused the video. Solutions in 3, 2, 1. Notice on the second one, we did have to capitalize on a reciprocal identity.